It's sort of, when I've been thinking about the maker mentality and CES, I've kind of gone circularly from the sublime to the ridiculous, and then from the ridiculous back to the sublime. Because it seemed to me that in all the years that I was coming to CES, the products that you'd find here would be sort of closed up. And the idea was to buy one and use it for the purposes that it was built, and everything was sort of decided before you got there. And I think what we're witnessing now is a little bit of turning that on its head. And at the same time, the word maker itself has gone from being something that nobody had ever heard to something that everybody's using. And I thought that I would start this by showing how the consumer electronics industry is using the term maker by a video that somebody showed to me, which is this video right now called Moto Maker. So this is basically a way of configuring a new Moto phone to have its own color case and different color buttons, and they're calling that Moto Maker. And I think that's kind of interesting in the context of where we're coming from with Maker. About 6 or 7 years ago, some friends of mine started something called Maker Faire in the Bay Area, and at the time they did, very few people had actually heard the term, and we used to have to call it DIY. And DIY itself had an interesting background in electronics that dates back to the days of Heathkit and Radio Shack, where electronics really started out by people configuring things and then building stuff with components. And then over time, the hardware piece of things got more and more closed up until we found things that were completely closed up. In the past couple of years, however, things have started to change again, and I feel like we're at the beginning of something that is kind of like a return to the past, in which people can actually use consumer electronic products to build things, either through hardware or for software. Is Ayah here?
She's en route. She should be here any minute.
Okay. So we. Okay. Okay. So we have a kind of ordered presentation with Ayah's video is first, but since she's not here, I'm going to ask Hopscotch to.
You would play Ayah's video since she's not here.
Oh, okay.
And then we'll go to Jocelyn and talk about Hopscotch. I know this is.
Sure.
Makers always make things up.
Okay. Yeah.
At least it works.
And with perfect timing, Ayah Bedeir is coming up on stage to talk about the video we've just seen and her amazing company, Little Bits.
Sorry.
There we go. Perfect.
Made it.
This is so maker.
I decided to DIY the move here, so that was not a good idea. So hi, my name is Ayah Bedeir. I'm the founder and CEO of Little Bits. Little Bits, as you saw, is a library of electronic modules that snap together with magnets for learning, for prototyping, and for fun. And the way we think about it is that every sort of big piece of game-changing technology in society starts in the hands of experts and then needs to get democratized to be put in the hands of everyday people. In our case, we're focusing on electronics and particularly on kids. We want kids to understand the world around them, how a light goes on, how sensors work, how their cars communicate, how the Internet of Things is going to be relevant for them. And we want them to participate in this technology revolution and not just be passive sort of bystanders and see it happen to them. We've been around 2 years now. The product's been in development for over 5.5 years. And right now we have about 60 modules, and there's billions of combinations. And the idea is that we want kids to make their own circuits, their own toys, their own inventions and really problem solve and learn through it. We focus very much on making the product and the library gender neutral, because it's very important, we think, in sort of leveling the playing field. And as a result, we see a very, very high engagement with girls with the product, which is not an accident. It's a very sort of, what's the word? Deliberate decision. And we also really like to speak, never sort of dumb down the product to kids. We want to elevate the discussion and have them really participate in inventing things like adults are inventing, so they can make their own nest, or they can make their own smartwatch, or they can make their own robot, and they don't have to just point at something and have it purchased. So I have some demos here that I can show if people want, but other than that, I'm very excited to be part of this panel, and sorry again for the delay. Thanks.
Very impromptu.
Cool.
So can people hear me now?
I can hear you.
So when we set up this panel, a lot of the presenters have videos that they wanted to show, and there is an order to it. So I'd like to move on to Paul. And,
That's me.
Yeah, and then maybe we can circle back to you, Ayah, in a little bit. And I'm told that I can advance this.
Yeah?
Present.
All right, wait, go back one just for a second. Unless is it automatically playing? Oh no, that's good, that's good. So my name's Paul Hoover. I work for Artifact, and we're a design company in Seattle. And we design a wide range of products. Some of the things I've done recently, I made a touchscreen washer and dryer, in-flight entertainment system, and even collaboration tools for HIV researchers. But my focus right now is education. I'm really passionate about the intersection between technology and education, and how we can bring up the next generation of makers. So in this video, I'll show just a couple of projects that I've done, some in my own time, some at work, some at previous. I used to work at Microsoft in the big-ass table Surface team. And yeah, so roll video. Maybe it'll work. Yeah. So this is a toy that has it has no moving parts or electronics, but whatever you put it on top of, it'll show inside the toy on the face through a fiber optic display. So it allows you to have thousands of toys locked away in one little toy. And what I'm working on now is a creative kind of programming interface where you can draw right onto the toy, program it, create worlds around it, stories, share those out, just to help kids learn programming and have fun. I'm also teaching at the K-12 level, focusing on new technologies to amplify old mediums. So this was a culminating work for a first grade class. We made a fun Lego Star Wars video where kids used normal mediums, broke them up into teams of 5, and we made a Star Wars video, and that was fun. And this was a game that a bunch of the same class helped me develop, where each kid would draw a level, and then we digitize that, put it into a game, and share that out with their friends and family. Trying just to instill in them the fact that they can make and they can be in control of their world. At the high school level, I help kids learn how to solve complex problems in the 21st century. So I help kids learn how to go through the design process, work in groups, prototype, get feedback, yeah, so I'm a designer, a maker, and I'm just trying to pass it on to the next generation however I can.
Thank you very much. And we're going to turn now to David Merrill, who is the founder and CEO of Siftio.
Okay, right. So Siftio Cubes are my company's product. It's a game system, but it's a game system that is inspired by some of the most basic, timeless playthings that kids have been playing with forever, namely blocks. And so we wanted to build this hybrid physical virtual play experience where instead of being based on the video game model of having a TV in front of you and a game controller in your hand, it was based on the play experience of sitting around a table with Legos or dominoes. On the maker topic, I'm sure we'll get to this in discussion, but my co-founder and I feel like we both emerged from the maker community. We prototyped this product with a lot of the same tools from SparkFun and using Arduinos and things that in the kind of DIY electronics maker community are just the common tools that everyone's using to build ideas. And we have a SDK, a software development kit that allows ourselves and our team and outside developers that aren't part of Siftio to build their own ideas on our platform. And I think that's one of the ways it's becoming pretty common for systems and platforms to enable a community of makers and developers to bend new platforms to their will and do what they want to do with it. So we're just this week releasing a game development tool that an enthusiastic developer in our Siftio developer community built so that people can build their own games for our platform without even having to program. So that's something I'm pretty excited about. I think it should be out on our site this week sometime.
That's terrific. And now I'd like to introduce Vikas Gupta, who is the founder and CEO of PlayEye. And is there a video here for yours as well?
There was. I don't know if there's a video.
Okay, here we go.
Probably not, I don't think there's probably a video there. So PlayEye was founded on one thing, one desire for all of us as parents, as founders. How can we have our children learn to program at a very young age, and using that as a skill to create stuff, using tools that they have in their hands, which is specifically touch devices, which nearly every child has. So that's where our approach is, which is creating more with software as much as with hardware. So we built a robot with two concepts in mind on that front. One, it allows kids to extend the robot using interfaces, using things they can design or things that they can actually get from us, or with Legos and so on to build on top of this. But it also uses the software medium on a touch device to build and create on top of this. So everything that we created on the robot is programmable, is editable by a child. Also, we open the same platform up to developers, where developers can create any kind of an application for the robot and make it available in the ecosystem on Apple and Android devices. So in many ways, we take this robot as a way to open up the ecosystem of what people can create, whether it's a child, a parent, a teacher, or a developer. And that's what we really see the robot going forward as a platform for people to create as much as with hardware as with software.
So thank you. And we have a new addition to our panel from the Hopscotch team. And
Yeah. Hi. My name is Jocelyn Levitt. I'm sort of a last-minute addition to the panel. I'm the CEO and co-founder of Hopscotch. And sort of listening to the rest of the panel here, it seems like we have like a lot of nice theme: hardware, and software. And we are a platform in which kids can learn how to program on tablets, exclusively software. Much along the same lines as a lot of these guys, we recognize sort of the modularity and the fun that kids have with these open-ended modular blocks and pieces. And what Hopscotch is a way for kids to use blocks of software to build little games, animations, and little applications. And we were sort of inspired by there are a couple of different visual programming languages, and we sort of wanted to create a visual programming language that was exclusively for mobile devices, recognizing that kids are really excited about mobile devices, but for the most part, while they're ubiquitous and they're really compelling for kids, they're pretty closed off systems, and you can't sort of tinker with them the same way that you could maybe 30 years ago when computers first came out with with an Apple II. You kind of had to know how to program a little bit. You had to know how to work on the command line to be able to play and even use the computer. Now a lot of touchscreen devices are just sort of these closed off boxes. And we recognize that that's not the greatest way for kids to be able to understand that they can actually create their own software and their own toys. And so with Hopscotch, we wanted to build something. I wish I had a video presentation, but afterwards, or maybe later, I can do a demo on the iPad of how it works. But
Do 3, little switch there.
Yeah.
oh,
Maybe we can do a demo?
oh, great, thanks.
I just love having a bunch of makers. Like, do you think they know how to use this equipment? You guys probably could figure out how to hit 3.
Oh, thanks. Okay.
Is it
So-
going to be this thing?
This might work.
This maybe?
No, this one's 3.
Also, something else while he's
Oh,
setting
I
up, I wanted to mention, Ayah had talked about this, and I feel like in some ways she's sort of a kindred spirit in the hardware world, but we were particularly interested in getting girls interested in programming early on. And the original impetus for this was as a toy for girls to become engineers, and we sort of made it more broad, but it was designed intentionally to be very gender neutral, very friendly to girls, and we are also very proud to say that we see about 50% of our users are girls, and they're designing girl games, and it's good fun stuff. Cool. Okay, so
Oh, there it is.
I guess we're sort of doing a demo
Yeah.
for me. But yes, as you can see, these are all sort of blocks of software. And what he's doing is that he's building a script right now of using the different blocks of software. He's got, if you see the cupcake in the top left corner there, that's what he's programming. It's an object-oriented programming language. So the idea is to give, yeah.
Not bad, all right.
Yeah, and one of the things that you can do that we think is particularly cool is the event handler drop-down at the top, where it says when the play button is tapped, you could do it so you could change the event. So if you wanted to scroll, you could do when, when the iPad is shaken. If you scrolled up a little, there's one that say when I hear a loud noise.
Oh, cool. Really?
Yeah, if you scroll, yeah, when the iPad detects a loud noise. So that's one that I like to do. Okay, so everybody, yeah.
Nice.
Yeah. Anyway. And then I don't know if you've seen Community yet, but we just introduced this in the top right corner there, where you see the download yeah. Go under newest. Uh-oh. Oh, okay, well, you're not on the internet. Anyway, we just introduced this less than 2 weeks ago, and it's been really fun seeing the stuff that kids have been programming and uploading.
Yeah.
So I encourage you can download. It's free in the App Store right now, Hopscotch. Check it out.
We found this from a teacher who said this using the iPads, they would be using Scratch, and they were saying that this particular app would just really change their school, change the way they think about programming, and because they had tablets, so it was sort of the catalyst of the tablets, of the language, and it really did make a huge difference. And so Jocelyn we called her up and said, you want a Cappy Award. And that
Yay!
was really cool.
Yeah.
So it's exactly what we love. It's when, we have no idea who these people are, but their products are making huge differences for kids. I'm just going to let that spin. I'm sorry.
That's a solar
One.
system animation somebody made.
So
Cool.
thanks everybody. I want to explore this distinction between open and closed, which you all seem to be hovering around in your own ways. So I'm just wondering, how do you view, is this really a change from the old version of what electronics was to a new version, or is this kind of an echo of what had always been around before this, but has now just started to become popular again? I guess what I'm asking is the maker movement something that's fundamentally open and new?
Well, I think there have been movements that sound like the maker movement for a long time. There was the arts and crafts movement, I think, in the 60s. And I think the difference now is that the kinds of, with technology, the kind of things that people are making and even kids are making is actually converging closer to the functionality of real products that you buy off the shelf. And it's pretty powerful. I think in terms of electronics, like the kinds of devices that kids can make using now with little bits or using at a lower level things like Arduino are actually similar to the devices that they might buy or get from their parents. So I think that's the exciting part, is that it's no longer just purely recreational, like building things that don't have very much functionality. It's really building real stuff.
Yeah.
And I noticed that all of you guys are sort of, you've got ingrained in you the notion of a platform, that, you know, you're building something that is fundamentally incomplete, you know, and it's up to the users to use it and make things from it. Is that sort of the
Absolutely.
concept?
I feel like all of these
Yeah.
are sort of tools and just a way, they can be combined in so many different ways. And it's really interesting, all the things. I mean, kids come up with stuff that I would never have thought of, and I don't know if that has been your experience as well, but yeah, I think the maker movement, I don't know if it's, I guess it's maybe it's called more of the maker movement now, but I think it's probably been around for a really long time. You always have these hobbyists and tinkerers sort of on the edge pushing technology forward.
Mm-hmm. Yeah, I'd echo that. I think, the maker movement, or makers have been around forever. But the fact that kids can connect now together and share and learn from each other through the internet, I think is, really made it into a movement. In regard to open versus closed, I think there's always been open and closed systems. I would hope the more we go forward, we could make all toys and games be open source, where kids can hack it, see the source code for whatever game or level they're working on, change it, augment it, remix it. I think that's definitely a big trend moving forward.
I mean, for me, I would, I'm going to try to speak loudly, but if you look at, thank you. If you look at sort of the beginnings of the maker movement, and like a lot of other movements, it doesn't start as a movement in the beginning. So they were makers, they were disparate, and then it started to become more of a community when there were outlets for them to expose their work and to get inspired from each other, including Make and some other really big players in the field that really made it a community. From a community, it became a movement when it started to make real strides in some different fields and started to grab attention and get people to quit their jobs and start companies. And this is not only with kids, this is adults, and this is retired engineers that started a second wind and a second career doing a new company inspired by the maker community. And then right now, it's really a lot more than a movement. It is a revolution. I strongly believe that the maker movement has become a revolution because it has inherent in it something activist. Everybody that I know, at least, that is involved in the maker movement, it's very difficult to make physical product. It's very difficult to even tinker. It's very difficult to move things around and create things that didn't exist. And so it requires a certain drive and passion and kind of North Star that guides you, and it's inherently activist. It's people who are saying, we are sick of larger companies going under the hood for 12 to 16 months, developing product that they just then throw upon us and we have to purchase. And we are sick of people not understanding what we need and technology going in directions that we don't agree with. And we're sick of products being developed for the lowest common denominator. I mean, people have different needs and different requirements, and sometimes what you need is not big enough for a market and for a company to make a product for, so you have to make it for yourself. And so for me, what's really interesting in the maker movement is it's that's it. I mean, it's starting to go mainstream. Larger companies, every week we have large companies contacting us, from large toy companies to large technology companies to large institutions, contact us and say, how do we become more like that? How do we become more like makers? How do we learn from this movement and innovate faster and be more creative and not obsess about these long development processes? And how do we go, ground up more? And that's for that reason I think it's revolution.
I'm tempted to open up to the audience. We have about 8 minutes left. I feel like, as I say, it's really interesting for us to be here in the Consumer Electronics Show. Kind of the planetary core of closed, and here we are talking about businesses which are based on being open. Yes.
So being open and coming to these spaces, what have been your biggest challenges so far? Is it getting distribution, awareness of parents? What has been your gating factors in getting your great stuff out there?
I mean, for us, I'll talk about little bits. For us, one of our biggest challenges is cost. Little bits, even though they're very simple and they look like they should be cheap, they're actually pretty expensive to make. And so if we want to operate in the toy industry and in the electronics industry, we have to embed margins that are, 50 points for the retailer, and then 10 points for the rep, and then points for giving free shipping and counting returns, and all these different cost structures that you have to, all these added costs that you have to embed in your cost structure. It makes it that if we wanted to sell the product and make everybody happy, including ourselves, a kit, our basic kit would need to cost $220, and that's a lot of money. And so we decide to make it for $99 and take the hit ourselves and ask for partners to take the hit with us while we get to volume, because electronics is still a volume game. And so if you don't get to the big price breaks, you're not going to get the big margin improvement. So for us, that's been the biggest challenge.
So I'll add a little bit from our perspective. So when you're building the platform, we wanted to be open, and we wanted children to use it to create more stuff. So we started actually with a very different perspective. We wanted to make it a more modular kit to get kids build their own robots. And we wanted it to be something that, at the same time, they can translate that to software, and the software could allow them to extend the same experience beyond that. And we found that became a big challenge for us. Because if I build a robot, another child will build a very different robot, and same software wouldn't work across the two robots. And that became a big hurdle in how well this could scale, and being something that could build a big enough community where people want to share programs for their robots. So the approach for us was what part becomes closed and what part becomes open. And the approach we've taken is, let's make software a lot more open, and where we can actually let kids create more with software and give them something that's, and again, the other challenge with modular kits, and I think as I alluded to some of it, is every single piece, when you build modular kits, each piece becomes expensive. And as you build more and more modular, it becomes very expensive overall. If you're able to package it enough power to give kids that they can do more with software, they can actually reduce the price down. So that's one of the other challenges, is price becomes a big factor in what the approach you take to the product you want to present to kids.
I have a quiz for the audience. And who said these words? Every time you teach a child something, you prevent them the opportunity from discovering it themselves. Anybody? Really? Seymour Papert? That's a great guess. And you say Papert? Well, thank God there's someone with gray hair up here on this panel. That would be Jean Piaget, and Papert was one of his colleagues and worked closely with him, so you're not far. But maker, and I love what you were saying about the maker thing, it's really constructivism, which Papert called constructionism. And there's a bit of a debate about that, but of course, Papert got Piaget got his ideas from Froebel. So we're all standing on the shoulders of giants with this, but the idea of the child constructing their own knowledge inside their head is very powerful, and I think that's the theory that all your work is grounded in. And it's great to see this coming to life again.
One thing that when Robin asked me to come on this panel, I kept thinking of one of the slogans over at Maker Faire, which is, if you can't open it, you don't own it. And then I was thinking, gosh, how do all these big companies at CES, deal with this kind of mentality that you have to be able to open something up and reconfigure it the way you want it to be. And what I'm seeing here, especially with some of the hardware startups on the stage, is that they really have straddled that line between something that is both electronic and reconfigurable, and I think that's really admirable. So thank you.
So I want to do one thing. There is one person who is not on the stage who won our CAPI Award for Pioneer 2 years ago. That's Dale Doherty, and I really credit him with founding the concept of the maker movement. If you've never been to a maker fair, you're really missing something. And the important thing, and I think Ayah touched on it, Jocelyn touched on it, we are growing tomorrow's jobs, and we're growing tomorrow's economy. And actually, the one contention I've always had with Dale, he goes, oh, CES, it's just a bunch of old guys and their products. And I said, you know what? There's not an organization in this country that can't, and in the world, that can't benefit from a good shot of maker mentality. So I hope, if you've learned nothing else from this panel, is that you take this maker spirit back with you to your respective life places and put it in every day. And I see a question.
Hi, I see online collaboration, and you guys have tested, well, you have good things to say about that. Have you seen any use of your devices in like an after-school club or a crafting hobby store, or where you get face-to-face interaction? Have you any ideas on how that might look or work?
Well, yeah, just briefly, we've seen after-school programs use Siftio cubes as an activity. In an earlier generation of the product, we had a tool for making simple game scripts, much simpler than the one I mentioned before, where you could put in your own content and you'd have ordering games like make a sequence of letters to spell a word or a sequence of words to spell a phrase. And so we saw some activity in after-school programs where they would use it as a treat. This is like different than what you did during the school day, and so here's a neat activity you can play with that's interactive that you can customize. So we did see that.
Any other questions? Okay.
Could somebody invent a microphone?
I kind of want to add on what you just said. We actually have used Siftio and Littlebits in after-school programs at both university level. University that I partnered with is doing an after-school program called Teaching High School Girls to Program. And so they're using one of the Siftio products that you mentioned as well to help them learn how to do basic programming from object-oriented, and then Littlebits from the robotic side of things, or a circuitry board, I should say. So yeah, and then lots of libraries are also doing Littlebits in terms of that maker spacing idea, where let's build something today instead of sit and read.
And I saw another question.
Robin, over here.
Oh, wait, all right.
Hi, my name's Jeremy. I'm with Microsoft and Xbox. Paul, I think we've met before. My question's around failure. I'll come grab you after. My question's around failure. So as we know as makers, we encounter failure a lot. It's how we learn, right? So I'm curious if you guys, any of you could comment on how you deal with failure in your products, teaching children that failure isn't necessarily a bad thing, right? Like if we learn this way, and it's important to impress that failure is okay, you learn from these mistakes rather than avoid it in the future. I'm just wondering if any of you can comment on how you handle those types of scenarios where you have failure in the face of the product that you have and how you deal with it.
So I'll add very quickly something to that. So failure is actually something we spend a lot of time allowing for and with software. So for example, one of the core parts of how kids learn to program with our robots is you can teach the robot to play music. It comes out and plays a xylophone. And one of the things, the big aspect of failure there is that actually failure leads to serendipity. It leads to discovery of something new. And we didn't want failure to get in the way of kids' experience in a way that it's not fun, it's so frustrating. So we wanted to allow for failure in different ways, and failure could actually lead to more fun in some ways. And a lot of testing, we also find that some things that are unexpected actually engage children much more than anything else. So allowing for the unexpected discoveries was important as well, and some of this stems from just children doing things not the right way, not the way we asked them to do in some way. So that's actually something very core to how we look at the experience with the creating stuff with the robots in general.
All right, up here we got little bits.
One last question over here.
Yeah, go ahead.
Quick question. Little bits I can find everything mentioned on the stage. I'm having difficulty getting Siftio and Artifact. Can you tell us where those are available?
So the Artifact little monster here is not available yet. Still in concept. So hopefully someday soon we'll find a partner to help us out.
On Siftio, we sold out. We this holiday cleared out our inventory, so I don't have a date that I can tell you right now, but stay tuned.
Okay, thanks.
How cool is it that you get to videotape the founder of, there she is, Little Bits, playing with Little Bits. Right here at the International Consumer Electronics Show.
This can be on carpet, but I mean,
Wow.
I just wanted to say thank you very much for incorporating Little Bits in your program. The interesting thing is when I first started Little Bits, it wasn't made for kids. It was really for designers and engineers to prototype with electronics. That was mainly the purpose. And then suddenly I went to a maker fair, and kids started to like attack the booth and stayed there for hours. And I had a mom that asked me, like, please pretend that you're closing down the booth because I want to go home. And then I realized, wow, there's a big opportunity to affect how kids learn. And so we started to do some of our product line for kids. And we didn't have an education department. And one day we were looking at our sales and suddenly realized that we had about 500 schools that were using Little Bits, schools and after-school programs through no effort of our own. Basically, we just gave them 50% education discount. So now we're putting a little bit more effort into that. We're starting to help them. We have teachers that are coming up to us and saying, like, we can develop curriculum around this that can impact the Common Core and can actually, really aid the curriculum with things that are now required. We don't do the curriculum ourselves, but we want to support them in any way we can. So for us, it's really about just providing the tool and then each person.
You got your own batteries.
Yeah.
That's cool.
That's a little bit of branding obsession.
You
Yeah.
also borrowed from the egg carton as a
Yeah.
packaging, which is a very nice.
Yeah, well, we try to be, electronics are not sustainable, but we try to be sustainable where we can, kind of like help things.
We like to put the play in kids at play.
Nice.
Robin?
And
Yeah, I have a question. Specifically on Little Bits, you kind of touched on it. You found that kids are really interested in it. You have a problem with getting child safety testing, getting things certified for kids, because you're kind of pushing them down to what a toy is.
Yeah.
For all that time.
So just to repeat the question for those who didn't hear it is there, specifically with Little Bits and probably the other hardware devices, is there an issue with child safety and getting approvals for distributing electronics?
So there is actual safety and then there is regulation. So in terms of actual safety, we put a lot of effort and design time, and that's part of why the product is expensive to make sure that it's safe. So Little Bits are 5 volts and they're under 1 amp, so everything is very safe from a voltage perspective. Parts that are batteries are covered so that you don't have to worry about something shorting or being dangerous. So we embed a lot of engineering, like actual product safety in the product. But then the second piece of it, which is like more the paper pushing, checking the box with the regulators, that's very challenging because the things that the regulation bodies, the Consumer Product Safety Commission and stuff like that, the things that they single out as worrisome for safety are completely like irrelevant. And for example, like a lead-free solder is something that does not exist. We spend 9 months looking for that. It does not exist. It's in every single electronic component that you see around you, and yet they mandate something like that. On the flip side, something like a battery shorting and something catching fire is something that they don't check for. So the things I find the safety regulations to be really. How to say it nicely? Archaic, to say the least, yeah, and really not real. I mean, as an engineer, I know that there are things that we've sent out that have actual safety hazard, and we've redesigned them from the ground up because of that, and they passed, and it's ridiculous.
All right. Stuart, ready?
Thank you very much, guys.
Thank you, panel. Stuart, excellent job moderating. Good work.
Good work.